4.2 exponential functions. So we're going to be doing a variety of things with these exponential functions. We're going to be just plugging in numbers and seeing what they're equal to. We're going to be graphing exponential functions and doing some logarithms or solving with logarithms with your calculator and some word problems. So a little bit of a variety today. You need something good over there?
Yeah, just you.
What is happening? Okay, f of x for all of these problems is going to be 3 to the x, and g of x is going to be 1/4 raised to the x. And it says find each of the following. Round answers to the nearest thousandth as needed. So if it's not a nice even number, then we'll be rounding, but we're doing the ones that should come out nicely. So, let's start with 14. F of -3. So what that means is in this equation up here, anywhere there's an x, we're putting -3. So we're going to have 3 raised to the -3. Now, anyone remember what a negative exponent does?
Like, puts it under 1.
Yeah. So I had Mr. Cass as a teacher, and his, as he liked to call them, Cassism for this was put it where it ain't, make it positive. So in this case, it's going to be moved to the bottom, so it'll be 1 over that, like Tristan said. But if it was already on the bottom, we would just be moving it to the top. So we are going to think about this as 1 over 3 cubed. And so that we're bringing the whole thing to the bottom. So we're putting it where it's not, putting it where it ain't, and we're making it positive. So we're changing the sign of the exponent. So what is 3 cubed?
9. No, 27.
27. So this is going to be 1 over 27. Hey, you caught it, though.
Yeah. I was thinking 3 times 3.
I figured you were just adding 3 plus 3 plus 3.
That's probably what I was doing.
People do that, too. 16. G of 3. So I'm putting 3 in for x up here. So this is going to be 1/4 raised to the 3. So when I have an exponent that's on a fraction, it's whatever that exponent is going to the top of the fraction and the bottom. So this is basically 1 cubed over 4 cubed, but 1 cubed is just 1. So 1 over 4 cubed. What is 4 cubed?
16 times 3, 64?
I think so.
Oh, wait.
Yes.
64, yeah.
Let's see. How about 20? F of -5/2. So F was 3 to the x, so this is going to be 3 raised to the -5/2.
Oh, don't you gotta do the square root thing?
Okay, yep. So an exponent that is a fraction, the denominator of that is the root that we take. So we'll be taking the square root. The top is the power that we raise it to. But I've got a negative exponent, so what should I do first?
Put it over 1. Put it under 1.
Yep, put it under 1. So I'm going to put it where it ain't, make it positive. So 1 over 3 raised to the 5/2. And now that's going to give me 1 over the square root of 3 raised to the 5th power. And I would be fine if you leave it like that, but I'm going to see what that value actually comes out to, just because I'm curious. Nope, raised to the 5. All right. You can leave it like that, or you can give me the decimal 0.064. But I would just leave it that way because less work you have to do. 22. G of negative 5/2. So same exponent, but we're doing it on the other one. So G of x was 1/4 to the x. So 1/4 raised to the negative 5/2. Any ideas what to do with this one?
Do the thing, whatever it ain't.
Yep, so because it's on a fraction, what I'm doing is I'm just flipping my fraction over. And in this case, there's just a 1 on top, so the 1's going away. But this would technically be 4 over 1 raised to the negative 5/2, but the 1's just going to go away. Or, sorry, to the positive 5/2 then. But the 1's going to go away, so I'm going to have 4 to the 5/2 because square root of 1 is 1, 1 to the 5th is 1, so it's just going away. But if it was like 3 or something, then we would have to keep it, obviously. So now what?
Could be the root thing.
The square root, so this is going to be the square root of 4 raised to the 5th. Square root of 4 is 2, so I've got 2 to the 5th, and what is 2 to the 5th?
32.
32. All right, any questions about those ones? Cool. So now we're going to apply what we just did so that we can graph exponential functions. So these ones, the instructions literally just say graph each function. I do it by plotting points. There's other ways you can do it, but plotting points seems to be the easiest way and the best way for people to get them right. So that's how I'm going to do it. 28. F of x is equal to 4 raised to the x. So I like to make a little table, and I pick 3 points usually to do it. So I'm going to do basically an XY table. I'm going to do for like a whole number, like 4 raised to a power. I usually try to do -1, 0, and 1 just because they're easy numbers to work with. And so I'm going to evaluate each of these points, the x and the y value, and then I'll plot the points. So if I put in -1 for x, so if I had 4 raised to the -1, what is that?
1/4.
1/4. If I put in 0, so if I had 4 raised to the 0, what is that? 1. And then if I put in 1, so I have 4 raised to the 1, what is that? 4. So now you can graph it. And so I'll usually put on the graph the points that I've checked. So these make ordered pairs. So at -1, it is 1/4. So somewhere in here. At 0, it's 1. And at 1, it is 4. So it's all the way up here. So these graphs, these are exponential, so they look like this. So it comes across pretty flat. It never crosses the x-axis in this case, so it never crosses, and it goes all the way up to infinity. So it just keeps going. And this would be an exponential growth function. Because as it goes from negative to positive, it's increasing and going up. Let's look at the reverse of that, number 30. F of x is equal to 1/4 raised to the x. So my setup is going to be the same. I'm still going to do a little table with -1, 0, and 1. So if I plug in -1 for x, so I've got 1/4 raised to the -1, what's that going to be? Four. Okay, so it flips it. 1/4 raised to the 0. 1. Anything raised to the 0 power is 1. That's why I like to use 0. And 1/4 raised to the 1. 1/4. So those are my ordered pairs. So now I can plot these points. So at -1, x or y is 4. At 0, it's 1. And at 1, it's 1/4. So this one is good. And again, still doesn't cross the x-axis. So this one, it starts positive and moves to, or like it starts high and goes low. So this is an exponential decay function. Now, if you compare these two graphs that we just did, okay, what do you notice?
Opposite.
They're opposite, okay, because when we plug in those numbers, we had 4 raised to the power, we had 1/4, 1, and then 4, but when we had 1/4 raised to the power, we had 4, 1, and then 1/4, and so it just flipped the numbers because of what we started with, like that. Let's see. Let's look at 32. F of x is equal to 5/3 raised to the x. So, got my table. And I'll tell you, like, you don't have to use -1, 0, and 1, but it's my personal preference because it makes life way easier. So, I've got 5/3 raised to the -1. What happens to that? Flips it, and it is 3/5. How about 5/3 to the 0?
1.
And 5/3 to the 1?
5/3.
So this one I've got at -1, it's at 3/5. At 0, it's at 1. And at 1, it's at 5/3, so just a little less than 2. So this one's a little more tightly together. What type of function would this be then? Just growth or
Exponential
decay?
growth. Wait. I don't.
Which way is the graph going?
Growth.
Growth. Exponential growth. Um, 34. F of x is equal to 1/6 raised to the negative x. Okay, so with this one, we have to make sure we pay attention to the fact that it's to the negative x, okay, because that's going to change things when I start plugging stuff in. So I've got my table. So I'm going to have 1/6 raised to the negative 1. So what is that doing?
So that'd be 1, so 1/6.
Yep. So the negative and the negative 1 are becoming positive 1, so that becomes, or that just stays as 1/6. How about when I put in 0? 1/6, and it's got the negative, but I'm putting in a 0, and 0 is not negative, so.
So it'd be 1.
Yep. And then 1/6 to the negative, and then we're plugging in 1 for x, so 1/6 to the negative 1 is
6.
6. So at negative 1, I'm at 1/6. 0, I'm at 1. And at 1, I'm all the way up at 6. And what type of graph is this one?
Exponential growth.
Yep. All right. So that's like the easier graphs, okay? Now we're going to move into ones that have a little bit more to them. And with these ones, -1, 0, and 1 aren't always the best option still, but we'll probably just use that for consistency's sake. So 40. F of x is equal to 2 to the x minus 4. So, I'm going to set up my table again. Now, what's different about this problem compared to the ones we've been doing?
It has a -4. Or like it has another.
Yeah, there's another piece to it. There's a -4. Now, that is why sometimes we don't use -1, 0, and 1 because it can make your numbers like really crazy when you start adding and subtracting like giant numbers. 4 is not that crazy, so it'll be fine. But if they get really weird, we may have to change the numbers just a little bit. All right, so I'm plugging in -1 for x, so I have 2 to the -1 minus 4.
It'd be -3.5.
-3.5, because this becomes 1/2 minus 4, and so that would be -3.5. 2 to the 0 minus 4, -3, because that's 1 minus 4. And then 2 to the 1 minus 4, -2. So now, this one's going to look a little different because my y values now are all what?
They're like on the other side. Like they're negative, so they'd be on the bottom.
Yeah, so now it's going to be on the bottom instead. So, -1, I'm at -3.5. At 0, I'm at 3. And at 1, I'm at, or sorry, at 0, I'm at -3. At 1, I'm at -2. So this one, it's kind of hard to see what's happening. The graph's not exactly even, but it's going like that. These problems ask you to do domain and range, but we're not going to do that for these problems, just because I'm not that worried about us doing that part. 42. F of x is equal to 2 to the x minus 4. Okay, so notice that minus 4 is up in the exponent now as opposed to being down like beside it. And if you ever do like -1, 0, and 1 and the numbers are like super weird, you can go and change it and pick like other numbers that make it a little bit
Would this
easier.
be 32 though? For
-1.
no, it would be 1 over 32.
Well, yeah, 2 to the -5 then.
How would you graph make more?
Huh?
How would you graph that?
It would just be really close to 0. Like 1 over 32 would just be really close to 0. All right, so at -1, we have 2 to the -1 minus 4, which is 2 to the -5. So we would move that over. So that would be 1 over 2 to the 5th, which is 1 over 32. If I put in 0, so I have 2 to the 0 minus 4. That's going to end up being 1 over 2 to the 4th, which is what?
1 over 16.
1 over 16. And then if I have 2 to the 1 minus 4, that is 1 over 2 to the 3rd, which is 1 over 8. So this one, this is where I probably would say, like, pick some bigger numbers, but it's fine with what we have. I'm just going to spread out my 1 and make my 1, like, be way up here on this one just so we can visually see it a little better. So at -1, it's at 1 over 32, so that's going to be, like, super, super close to the line. 1 over 16 is going to be a little higher up, and then 1 over 8 a little higher than that. So I'm just making my graph like kind of obnoxious just because they're such small numbers to deal with. If I had done it like I'd been doing it, where it was like this, kind of, it would be like, and it'd be really hard to see what's happening. They almost look like they're like in a line. So I just made it super obnoxious so that we can see it, which is fine. All right, still graphing. One more. It's like a different category of graphing, but anyways, I don't know why they separate it like this, but they do anyways. So 56. F of x is equal to 1/3 to the -x minus 2. All right, so if I plug in -1, I've got 1/3 raised to the -1 minus 2. So that's 1/3 to the 1 minus 2, so it's 1/3 to the negative 1, which is what?
3.
3. If I plug in 0, 1/3 raised to the 0 minus 2, so 1/3 to the negative 2 is also known as 3 squared. 9. And then 1/3 to the negative 1 minus 2.
So that would be 27.
Yep, so that would become 3 cubed. So that's 27. Now, that's a pretty big number to graph, right? So I would maybe consider counting by 3s instead on my y-axis when I do it, just so it's not quite so crazy. Alright, so at negative 1, I'm at 3. So I've done increments of 3 on my y just to make it easier. At 0, I'm at 9. And at 1, I'm all the way up at 27. Any questions about the graphing problems? Are we okay on that? All right, these next problems are solving each equation. So right now, you don't know logarithms yet, so I can't teach you to use that way to solve them. But once we learn logarithms, I can teach you that way to solve them because I personally think it's easier. But we are going to use a different method for today, and then when we get to the next section, we'll use a different method to solve them. But 72 is 125 to the x is equal to 5. So, what we're going to do, rules of not rules of exponents, I say, but rules of like exponential functions say that if you have the same base, so this is your base here. If you have the same base, then whatever their powers are should be equal. So you can set like their powers equal to each other and so solve for x that way. So I need to rewrite 125 in terms of 5. So how might I rewrite that?
Would it be 5 to the 3rd?
5 cubed, yep. So then I'm going to rewrite this as 5 to the 3 with the x as well, because the x is already there, is equal to 5 to the, in this case, this 5 has a 1 on it. So then I can take their exponents. Okay, so 3x is going to be equal to 1. So then x is equal to 1/3. And you just solve that equation. (76) 5 raised to the 2 plus 2x is equal to 25. So what should I rewrite in this one?
It'd be 5 squared.
I'm going to rewrite 25 as 5 squared. So I have 5 to the 2 plus 2x is equal to 5 to the 2. So then 2 plus 2x is equal to 2, because we now have the same base. So 2x is equal to 0, so x is equal to 0. All right, these ones are a little different. We don't have to rewrite them now. We have to do something a little different. So 84 x to the 2/5 is equal to 16. So now I just need to get x by itself. So it has an exponent of 2/5 on it, okay? Now that 2/5 for that x means that I square it and I take the 5th root of it. So I need to basically undo that. So how would I undo squaring and taking the 5th root?
You put the it's like the 5th root. I think I know it right. For 16, you mean? Like for.
Well, I've got x to the 2/5 and I need to get x by itself. So what do I need to do to both sides to make x just be by itself?
By 2/5.
If I multiply by 2/5, I'm just going to have 2/5 x to the 2/5.
You have to put it to the
Raise it to the 5th power, is that what you said?
Oh,
Yep.
okay.
I'm going to raise both sides to the 5th power first. So I'm going to have x squared is equal to 16 raised to the 5th, which I'm going to wait on that for a moment before I multiply that out. Try to make it slightly less miserable. Now what?
square root.
Yep, take the square root because then that puts x by itself. So x is equal to, I'm going to write it this way, the square root of 16 raised to the 5th, because it doesn't matter which order you do them in. Now the square root of 16 is 4, so x is equal to 4 to the 5th, which you probably don't know that number off the top of your head, so at that point we would
256.
need a calculator. Is it? Nope, you gotta multiply it again. You need 256 times 4.
9. Does it start with a 9?
No.
1? Start with a 1. 1,000. It's well, under 100, right? 1,084.
Almost. Your third digit is wrong.
1,086.
Third digit is wrong.
1,094. 1,074. 64. 54. 44. 34. 24.
Yes.
Oh,
1,024.
I was close.
You're on the right track. All right, let's do another one. 86. X to the 3/2 is equal to 27. So what would I do to this one?
Same thing, you do the third power or whatever. Do the square root of 3. I don't know. The same thing.
So it was being
Square root of 2,
cubed.
Square root of 2 or whatever. Cube.
It was
Yeah.
being cubed, so to get rid of it, I need to take the cube root of both sides.
Yeah.
So this is going to be, and it doesn't matter what order you do the things in, you could do it either way, but so this is going to be x to the 1/2 is equal to the cube root of 27. You know what the cube root of 27 is?
3.
3. So x to the 1/2 is equal to 3. Now what?
Would be x equal to 9.
Yep, so you squared both sides. So x is equal to 9. All right, we're going to do one word problem. Number 100. Find the present value that will grow to $45,000 if interest is 3.6% compounded monthly for 1 year. All right, so your formula that you have in your notes is A is equal to P times 1 plus R over N raised to the Tn. N is the number of times it's compounded. T is the number, or like the time in years. R is the rate. And P is the, where is it? The dollars deposited into the account. And then A is going to be the like amount that we're or wait, this book uses different letters than I usually use, so let me make sure we're good. Oh, sorry. P is the present value. What we're trying to find is what we need to deposit for it to get to this $45,000. These problems are worded differently than the other book does. So, the amount that it is growing to, okay, is 45,000. That's going to be A. The interest rate is 3.6%. It's not Chapel.
You know Chapel?
No, Chapel's smart. I don't know. Couldn't tell you. I would love to know. They don't tell us
I
anything.
won't be there for Chapel.
So this rate is 3.6%, but I need it as a decimal, so I need to move the decimal place left 2, so 0.036. Did you just think I was going to teach through Chapel?
I was like, maybe, well, yeah.
Mr. Webster said they couldn't make it to the people teaching the lesson.
Also, I won't be here for this class tomorrow.
For this class tomorrow?
Well,
Tomorrow is just going to be a work
I
day.
have an appointment at 9:45. So, might be here.
And then compounded monthly. How many months are in a year?
365 months, 12.
Months is 12, so N is equal to 12, and N is the number of times it's compounded per year. And then T is the number of years, which is 1.
I gotta catch up.
So I'm going to plug these numbers in. So I've got 45,000 equals P times 1 plus 0.036 divided by 12 raised to the 12 times 1. Now, I'm going to show you this lovely trick for how to type a fraction into your calculator that you may or may not be aware of, because people are usually mind blown when I do it. So, I'm going to solve what's in this parentheses right here first, because it's being multiplied by P. So, I'm ultimately going to divide 45,000 by whatever I get. But I'm going to do, I'm going to go ahead and put it in parentheses so that I can solve it all together. But 1 plus, if you hit alpha and then y equals, it brings up these different fraction options. So the first one is n over d, which is numerator over denominator. And so then you can type in the number like that. So it actually is written as a fraction, so you don't have to worry about typing something in wrong and it like throwing your answer off. Close my parentheses, raise it to the 12 times 1, so raise it to the 12. So that's this piece right here. So now I need 45,000 divided by all of that stuff. So I'm just going to do that, is equal to P. So if I do 45,000 divided by, and then you hit second, and then the little negative sign at the bottom, that uses the answer that you just found, and it gives it to you. So the amount that they need to deposit in order for it to be $45,000 in a year is $43,411, and it is money, so we have 2 decimal places, so 15 cents.
I always wonder how you do the fractions. Like that.
Now you know how to type them in. The ones I've been doing with pre-calc, because they just did this stuff, the ones that they've been doing, they have these like massive like fractions that they have to type in. So they've been using this method because it makes it way easier.
I should just like go on YouTube and look it up.
All right, I'm going to go ahead and tell you what your homework problems are, but you'll have time in class tomorrow to do them. So the stuff from 4.1 you need to have done before you come to class, but 4.2 you'll have time in class to do. And I can do another word problem since we only had time to do one tomorrow. All right, 11, 17, 21, 31, 35, 45, 47, 55, 75, 85, and then 99 and 101. Those are both word problems.